In this short video, we're going to take a look at how we configure IS to IS in SROS. We're going to use our usual 6-node network. SROS 1s, 2 and 3 are going to be level 1, level 2 capable, so that's the default. SROS 4 is going to be level 2 only because it has no connectivity to a level 1 domain, and SROS 5 and 6 are going to be our level 1 only routers. So first thing to do over on router 1 is we're going to make sure that nothing is actually configured. We see IS to IS is in a not configured state, and to make it configured we simply enter the process. You can see now instance 0 has gone to an up state. And we want to configure an area. We can have up to 3 areas. We're going to call this one area 5 because we're going to talk to SROS 5 here. We're going to put our system interface in, just so you see the system interface. It's 192.0.2.1/32, and we're going to configure our interface to OR5. Now, the interface type options we have with ISIS are point-to-point and broadcast. Now, broadcast is the default, and it's going to mean we have a DIS election or a designated IS election, similar to the OSPF DOR election. For this example, I'm going to configure point-to-point interface type, and then move over to router 5. So router 5 has to go through the same process. We need to give it an area, 49.0.0.0.5. We're going to tell it has a level capability of level 1 only, right? We put in our system address, and we're going to put in 2 or 1, but we're not going to specify the interface type. So if we take a look at the detail output for the interface, and we match on type, we're going to see the operational type is broadcast. Now, what this means is we won't have an adjacency because the interface type has to match both sides of the connection. If we face this in the NRS2 lab and we don't have access to the far end router, it's a black box, for example, we need to be able to debug the hello messages so we can figure out how we need to set it. So to do that, we first configure a log. I like to go with log 8 from debug to session, and then debug router ISIS packet. So first in, we see we're transmitting hellos. It's a L1 LAN hello PDU, which basically means locally we're level 1 and it's a broadcast interface. The received is PTOP, point to point, whatever you want to call it. So obviously they're not compatible, so we get a wrong hello message. So to fix that, it's easy enough. ISIS interface 2 or 1, interface point to point. Now we should have an adjacency, and we do. We see the usage is L1, so that's level 1. And we have information in our level 1 database. We don't have level 2 information because we're not a level 2 router. So if we look at the details, we see all the information from both OR1 and OR5. Now, the routing table on OR5 is sparse at the moment. All we've learned is the system address of OR1 because we're directly connected to the interface to OR1, and OR1 has no other interfaces in the IS process. So next we're going to configure our connectivity to router 2. Leave this one as broadcast as well, just so we can see the DIS, and configure IS to IS on OR2. This time we're going area 6. As we see here, 2 is connected to 6, so we're going to have to at least be in area 6. It's a level 1 2, so we don't change that. We put our system address in. Actually, we'll leave that out for the moment. Interface 2 or 1. And that should be sufficient for OR1 to have 2 adjacencies. So we have a level 2 to OR2 and a level 1 to OR5. So how has this changed the routing table on OR5? We have the addition of a couple of paths. We have the connection that's between OR1 and OR2, 10.1.2.0/24. We also have a default route that is usable via the link to OR1. So if we look at the ISIS database, not necessarily the detail, we see we now have the attached bit attribute set from OR1. What this means is OR1 is a level 1-2 router that has connectivity out of this particular area. So this causes the generation of a default route and installation into the RIB, and consequently the FIB. So if we look at line card 1, we see ISS has caused the installation of this particular path via OR1. So can we reach router 2 sourced from ourselves? Nope, of course we can't. Right, so we don't have a path directly to it, but we follow the default route, but we haven't actually put in the system address of OR2. So while OR5 is not going to know how to get to OR2 directly, OR1 should, because they're part of the same core. So fix that. We put in the system address, and now we can ping it. Now we still don't have a path to get to 192.0.2.2. We only have 1 and 5, but OR1 now has it. And that's how we set up the basics of IS2IS.